Hello everyone and welcome back. So continuing on with the World Data Storage System in this video, Nelson is going to be implementing the database index. So Nelson, database index. We've talked about the database and the index. Talk a little bit about what this is going to need to do, the database index.
All we're really going to be doing is building a class that sort of abstracts the idea of interacting with the interface as described in the original video that we did.
Okay.
So the responsibilities of this class are basically just to take in vector2 coordinates and then either get or set longs based off those vector2 coordinates. So we're going to have a method like get first record position given the vector2 and set first record position given the vector2.
Gotcha.
Okay, so we'll, I guess, start by creating a database index class. And I guess I can just go ahead and stub out his main sort of responsibilities, which will be get first record position, vector2. You gotta be kidding me. And then return 0, public void set, first record position. Okay. So yeah, actually we can go ahead and write some tests for this, I guess. The public, this is going to be essentially the public interface for this class, so it's pretty straightforward, but we might as well throw in some tests to see how well it works.
Yeah, and it's again, it's just a good way to also introduce people that are new to unit testing how to go about doing this.
All right, so I'm just going to do a setup method. Set up. There we go. And a tear down method. And these guys are just going to go ahead and instantiate a database index. Database index. And then tear down isn't going to do anything at the moment. So the first test that we're going to do is something, let's go ahead and make sure that setting a record or setting a position, setting something doesn't throw an exception, I guess we could say. So setting or doesn't throw exception. And about test naming, you generally want, as a rule of thumb for test naming, you're going to be seeing your tests in a list. And they're either going to have next to them if they failed or succeeded. So you're going to want to have a very descriptive name, even if it gets ridiculously long, because if you're working with hundreds and hundreds of tests, it'll be kind of obnoxious to have to click on each individual failed test to see what that test actually does.
Right.
So this is going to go ahead and set first record position, and I made that wrong, actually. The issue is that set first record position needs to have an actual position that we're setting. Or I'll call that position. So 0, 0, and then 0. And then I'll just throw it in a for loop just for fun. And I'll go ahead and just say I negative I times 2, just to throw a bunch of random data at it. And so unfortunately, this test will actually pass. So this was kind of a pointless test, but let me go ahead and show it to you guys. This does actually pass. So, yeah. But as far as TDD, generally that's what you would do. You're going to be setting, because if we, for example, were to ever introduce code in our set first record position that threw an exception, we now have a sort of safeguard against it, a smoke test, I guess you could say. So the next one is getting a record or retrieve proper record after set. Or how about records retrieved after set are correct. So then I'm just going to yank this code. And then I'm just going to say for var I equals 0, I is smaller than 100, I plus plus. And then I'm going to do database index dot get first record position new vector to I negative I equals or should equal or be I times 2. So does this test make sense?
Yes.
All right, so if we go ahead and run it, we will get an error. And that's because database get first record position always returns 0, which is obviously incorrect. So now we get to the point where we actually have to start implementing get first and set first. I'm going to implement set first, I guess. And the first problem is that the database index needs to know where it's going to get, or where it's going to be using the file from, where it's going to, what file it's going to be using for its index. So I'm going to go ahead and paste that in accidentally, then undo it, throw in a constructor for a database file system. And this is going to throw an error. I know why, because I didn't quite think ahead properly, but that's because database file system is private. I'm going to go ahead and cheat and make it public for now so we can run our test properly. So now that we have our file system imported, let's go ahead and go up here and pass in that information to our database index. So I'm going to say string directory is going to be, let's just do path combine test database. So that's going to go ahead and from the current location going to go into, actually let's just say test database and then not make path combine because that would be pointless. So this is going to, or sorry, path combine app domain, current domain, base directory, and then test database. And then we can probably make this a little bit cleaner. And it's still not very clean, so I'll break on that and break on that. Okay. So does that make sense?
Yeah, I'm having to try to keep up, probably like our viewers as well. But yes.
Well, what we're doing is we're instantiating a database file system. We're telling it to use a directory, test-database, relative to our current base directory that our assembly resides in, and then we're instantiating the new database index with that information.
Correct.
So we're going to need file streams for this database index, and we're going to be needing a lot of file I/O. So what I'm going to do is I'm going to just go ahead and instantiate file streams in the constructor, and then dispose of them when the class is no longer needed. And obviously we'll be implementing the iDisposable interface to properly handle that. So we're going to have a file stream equals file dot open file system, index file path. We want file mode, open or create, and then file access, read, write. Then we need a reader, and it's going to be a binary reader on file system. And then we need a writer, which is going to be a binary writer on file system. And then we're going to go ahead and create all these fields. And this should be file stream. And then all of these are going to want to be read-only because they're only set in the constructor. Okay, so now we have all of our streams set up, but now we need to close them once the database index is done with. So the database index is going to go ahead and, that was pathetic, implement the iDisposable interface.
And you know what? After you implement this, since breaking these videos up has been an interesting discussion in itself off camera. After the dispose is all in place, then let's go ahead and bring this one to a close so that we can try to keep these short. So it's about 10 minutes.
Okay. And then finally, because I implemented dispose, let's go ahead and call it in our tests. Dispose. Alrighty.
All right, cool. Okay, so let's go ahead. We'll just split this one up into a couple different parts. So we will continue with the database index as well as the database index tests in the next video. Thanks a lot.